that you're organized. So we're going to begin in 2.1 today, and we're going to be talking in this chapter all about equations. And we're going to You're welcome. So we're going to again talk about the difference between an equation and an expression. And remember, the difference is the equal sign. Now, when we worked with expressions in chapter 1, we couldn't solve them, right? When we work with equations in this chapter and beyond, we're going to learn how to solve equations. So we're going to be working with just some simple equations. So we're going to be solving some of these. And we're going to start off with a very, very basic equation. So this is what we're going to work with here. So when we have a question like this one, what we want to do is we want to solve it. And when I talk about solving an equation, that means I get the variable by itself on the left-hand side and the numbers on the right-hand side. Now what we do is we work in terms of opposites. So the opposite of addition is, of course, subtraction, and that's what this section focuses on. In 2.2, we work with multiplication and its opposite, division. So in this section, we're going to be focusing on the opposites of addition and subtraction. So I want to move that 5 over. Right now it's a positive 5, so we look in terms of opposites, and the opposite of a positive 5 is a negative 5. So we move that 5 over to the right-hand side, and then we have now solved this, and we have z equals now 9 minus 5, z equals now 4. Okay, so that's what we're working with there, and that's going to be z equals 4. And that's your answer. So we've solved it, and again, what do I mean when I talk about solving equations? When I solve an equation, that means you get the variable by itself. Okay, and this is a very, very elementary example. We just moved the 5 over, and we solved it. So solving just means you get the variable by itself, and it equals a number. So let's try another one. And we're going to try and solve this one again. So this one's a little bit more complicated. It has a few more steps. It's an equation because we have that equal sign. So the first thing that we do here is we use our distributive property. So we're going to use our distributive property to clear out these parentheses. So that's going to be our first step, is to just distribute the 4 and the 5 through. And really take your time. You don't want to make a mistake, so parentheses go first. That's our order of operations. When I distribute through, that gives me a 5z. 5 times 3 is that 15. 4 times z is a 4z. And 4 times a negative 6, that's a minus what? Minus 24. Is everyone okay with that so far? So all I did was distribute through. Now, we want to solve it like we did the last one. And so I want it to eventually look like this, where the variable can be an x, can be a z, can be a t, whatever variable we've got. The variable by itself on the left, numbers on the right. So how would we solve this? Well, we need to move things around. And you can do them in different order. What I like to generally do is I move the variables first. So let's go ahead and get all the z's on the left-hand side. So I have a 4z, and the opposite of that 4z is a minus 4z. Okay, you can later on do multiple steps at once, but right now we're just doing them one at a time. 5 minus 4 makes it a 1z plus 15, and that equals a negative 24. And I now need to get the z by itself. That 15 is a positive 15. I want to move it to the right-hand side, so what do I need to do? Okay, yep, move that over with subtraction. And now we've got our z by itself. And be very, very careful with your signs here. Negative minus another negative makes my sign negative. These go together. And what do we have? We have 24 plus 15. That's a 39. So that means z equals now what? Negative 39. Okay? Let's do some more of these. How about we try to solve this one? They're all a little bit different. So again, similar type of question. I used a different variable, so I chose to use an x instead of a z. And what do we need to do here? Okay, first thing we do is we distribute. Now, be very, very careful. This is a negative 6, so I like to circle it so I remember it's negative. And so I'm going to distribute that negative 6 through, and that's going to change your signs. So that leaves me then with, on the right-hand side, a negative 6x. Negative and negative makes it a positive 12. Now we can use the exact same procedure that we used a moment ago to finish this out. So what needs to happen here? I need to get the, I generally start with the variables, but you can move the numbers. Doesn't matter. They both have to be done, but I usually start with the variables. So I'm going to go ahead and move this 6x over to join the 5x. Now, what do we notice about the 6x? The 6x is negative, right? So what's the opposite of a negative 6x? Positive 6x. So we always work in terms of opposites. So I'm going to have to add that 6x to each side. Minus 5 plus 6x, that leaves you with a single x. And then we have a 14. These can cancel, right, because one's positive, one's negative. And it equals 12 on the right-hand side. How do we finish it? What would be my next step here? Move what? Move that 14 over, and how do we do that? Move that 14 over with subtraction, right, because that's the opposite of addition. And that leaves me then with x equaling now a negative 2. Okay. So again, we're just learning the very, very basics of solving these. And let's see, who still needs the homework packet? New homework packet? That's how we solve an equation like that. So move things around. Now, what about fractions? Well, the fractions that they give you in this section, we're going to have common denominators, and we can add them together for the x's. So let's work with one of these. Okay, so how about we use a minus third x plus 9. Okay, so we're going to start off with this one. Now, when we see the fractions, in later sections, we're going to learn how to clear them out. But whenever we see fractions, we always look and we see what we've got. And in some cases, it's not that difficult because what do you notice here? Okay. These have the same what? Denominator. So we don't have to get a common denominator because it already has one. And so what we're going to do is we're going to move that 1/3 over. And so if you struggle with it, okay, we're going to have to add 1/3 x to each side. And if you struggle with anything or need extra space, work it out over to the side. So split your paper down the middle, and you can work with it over here. And we've got 2/3 x, right, plus another 1/3 x. So those go together and give you 3/3x, which is then what? Yep, 1x, or just an x there. So the variables in this case go away and give you just an x. And then we've got a plus 5, and that equals now positive 9. Finish it. What would be my next step here? Okay. My next step would be to do what? Can someone tell me? Yep, and how would I do that?
Subtract 5.
Yep, very good work. Subtract that 5. And that leaves me then with x equaling now what? 9 minus 5, which is a 4. Yep. And again, we're just learning the very, very basics, but we need to make sure we're really comfortable with working with addition and subtraction. So now I'm going to pick some from our textbook to look at. Let's pick some random questions from our textbook to look at, and I'll put them on the screen. Let's do one that has quite a bit of things to combine together. How about page 111? We're going to look at question 70. And if you don't have your textbook with you, that's fine, because I'm going to put it up on the screen for us. So we're going to look at question 70 on page 111 here. And we've got 4x minus 6 plus 3x minus 6x equals 3 plus 10. So this one, we're going to do it exactly the same as we've done the others. All right? But what we need to do first, before we move variables over, is we need to look on each side of the equal sign. We need to see if we can combine like terms together. Remember, like terms have the same variables. So when I look here, let's see what we've got. If I look at the like terms here. So I'm going to do the x's first. The variables usually go first. And I've got a 4, I've got a 3, and I've got a negative 6. So 4 plus 3 makes it a 7x. Minus 6x makes it a x. And then I still have a minus 6 left over. And now we're going to go to the right. These are the same, right? They're just numbers. So 3 plus 10 makes it a 13. Now we should know what to do. So we've combined our like terms. We need to get the variable by itself. So what would my next step here be to do? Yep, add 6. Now we've got x equaling 19, isn't it? And that's going to be your answer for that question. Okay, let's try another one. How about we look at one that's got decimals in it? 76. Decimals are going to work just like any other number. We just use our calculator. So 4.0x plus 2.7 minus 9.6x here equals a minus 4.6x plus 2.7. Okay, so here's what we've got. Now, it's going to work exactly the same as the others we've done. If we have decimals and you want to, just use a calculator. If you struggle with things, just use a calculator. So let's see what we've got. Let's do the x's first. We have a 4 and a minus 9.6, so we'll do that. We've got 4 minus that 9.6, and that comes out to be a 5, a minus 5.6 x, and then we've still got the plus 2.7. And then the right-hand side, nothing goes together. So it's still a minus 4.6 plus 2.7 there. Okay, and I introduced this one because this shows us a new concept as well. We need to solve it, just like we've done all of the others. Okay, and how do we go about doing that? Move things around. So I'm going to add 4.6 to each side. So 4.6x gets moved over. Minus 5.6 plus 4.6, that leaves you with a negative x, plus 2.7 equals 2.7. Now sometimes students make mistakes here. What's going to happen with the 2.7? I need to move it over, right? Right now it's positive, so I would move it over with a what? Negative. And now we've got a negative x equals now 0. Okay, and that's what we wanted. And this does introduce another concept. This introduces the concept of that negative in front of the x. When we have solved all of the others, it didn't matter whether it was an x, a z, whatever variable it might be, it's always been a positive, right? It's always been that variable with no number in front. This one has a negative, so I need to get rid of the negative. So how do you get rid of the negative? Well, you can get rid of the negative by dividing by a negative 1. Okay, that's going to switch your signs. Right, and this builds into the next section, because in the next section, we're going to go over a lot more of these. Negative and negative makes it a positive x. 0 divided by negative 1 is still what? Still 0. So what's my final finished answer now? X equals 0. Okay, so whenever you have a negative in front at the end, you can get rid of it by dividing by a negative 1. That goes away because a negative divided by a negative is a positive. All right, let's look at one more of these, and then we'll move on to the next section. Because the next section is just working with multiplication. So let's look at one more of these. How about we look at question 78? So question 78, again, this one has fractions. Equals the 4/5 there. Minus 1/7 s plus 1/6. Okay, so first thing before I move anything around is I need to look on the left-hand side and the right-hand side and make sure that nothing can be combined together. These fractions on the left-hand side cannot go together because this one has an s and this one does not. But what about on the right-hand side? All right, we do have something that will go together. These can go together, can't they? So let's work with it. And again, if you struggle with the fractions, write them over to the side. So if we look at what I've got underlined here, we've got 4/5 plus 1/6. And we need a least common denominator. And what's the least common denominator of 5 and 6? Does anyone remember? 30. And now we'll go ahead and multiply this by 6/6. And this one gets a 5/5. We'll distribute through and finish this one out. So 6 times 4, that makes it a 24/30. 5 times 1 is a 5/30. Add those together and we get a 29/30. And that's 6/7 s here. Minus 3/4. Okay, so what we did was we worked on the right-hand side and we combined those fractions together. Now we need to go ahead and get the s's on the left-hand side. So what's going to happen to that 1/7 here? It's going to have to be moved over. So I'm going to use a positive 1/7 because this one's negative. And these have the same denominators, don't they? So they can go together. 6 plus 1 makes it 7. 7 over 7 is a single 1. So that's going to come out to be an S there. 6 sevenths and another seventh makes it 7 sevenths, which is 1. And then we still have the minus 3/4. And that equals 29 over 30. Now we can finish it. Okay, we got one more fraction to deal with here. What do we need to do next? Okay, we need to move that 3/4 over. Right now it's subtraction, so the opposite of subtraction would be addition. So we're going to add that over. And again, if we struggle with fractions, work them out over to the side. Okay, so let's see what we've got. We've got 29 over 30 plus 3/4. Least common denominator of 30 and 4 would be what? Okay, well, let's see. Okay, we got 30. Does 30 evenly go into 4? No. Okay, so then we double it. So 30 times 2 is a 60. Does 60 evenly divide into 4? Yes. That gives me what? 15. So what's my least common denominator? 60. Because 60 goes into 30 and 60 goes into the 4, just like we've done before. Now, what do I need to multiply the first fraction by? Can someone tell me? 2 over 2. Yep, very good work there. And what about the second one? What does it need? 4 times what gives you 60? 4 times 15. So that needs a 15 over 15. Now we can either use our calculator or just do this mentally. 29 times 2. That makes it a 58 over 60. 3 times 15, that makes it a 45, right, over 60. We can add those together, and that gives me then 58 plus 45. That gives me 103 over 60. So that goes together here. We still have an S left over because that hasn't went away, and that equals now 103 over 60. And that's as far as we can go on that one. Okay, that one was the most difficult question that you're going to see in this section. And again, if you struggle with fractions, work them out over to the side. Now in a later section, we're going to learn how to clear them out. But in this section, we're just going to combine them together. So that was 2.1. Now we're going to look at 2.2. And 2.2 is very similar to 2.1. Still solving equations, except instead of adding and subtracting to get rid of each other, we're going to use multiplication and division. So let's start off with a very, very basic one. Okay. 5x equals 10. How would you solve this equation here? 5x equals 10. Well, what do we need to do? Okay, we need to get the x by itself. I am not going to subtract 5 off, right? Why am I not going to just subtract 5 off? Because how does the 5 go with the x? Okay, the 5 is in front of it. And so the 5 is in front of it, and that is 5 times x, right? If I say this out, that is 5 times x. So that's 5 times x, and what's the opposite of multiplication? Division. Now, whatever we do to one side, we have to do to the other. So we need to get rid of that 5. This is multiplication. So what undoes multiplication is division. Okay. And now we can 5 divided by 5, cancel that out. That leaves you with an x. And 10 divided by 5, well, that leaves you with a 2. And that's it. Okay. Now, again, that is a very, very basic one. But we understand the concept of what gets rid of multiplication, division. What gets rid of division? Multiplication. Now let's do another one. Let's say I put a negative in front of it. Let's try to solve this one. Again, very simple. Now I need to get rid of the 8 in front, and it is negative. So how do I get rid of that? It's multiplication. What's the opposite of multiplication? Division. So I'm going to divide both sides by a negative 8. Those can cancel, and that leaves you with an x by itself on the left-hand side. And 32 divided by negative 8, what would that be? Positive or negative 4? Be positive over negative makes it a negative. So that would come out then to be a what? Negative 4, isn't it? Okay, so there's your answer on that. So if it's got a negative in front, you've got to divide by the negative. Sometimes you may have to combine like terms together and then divide out. So let's look at one of these where we have to do a lot of combining things together. Question 70. And this is going to be on 117. Question 70. And what we have is we have a minus 5x plus 4x minus 8x equals now 0. So we need to solve this out. So the first thing we do before we divide is we look on the left and we look on the right. We look at each side and we see what we can combine together. Well, if we look on the left-hand side, these are x's, and these can all go together. So we have a minus 5, positive 4, that makes it a minus 1, minus 8 makes it a minus 9x, and that equals 0. And how do we get rid of the negative 9 in front of the x? It's linked to the x by multiplication. And what's going to undo my multiplication? Division. So I divide both sides by negative 9. Those are all going to cancel. So again, we are left with x equaling 0 divided by negative 9 leaves you with a 0. So there's your answer. Simple enough. X equals 0. If you've got parentheses, you're going to have to get rid of the parentheses first. So, for example, question 78. This one has parentheses. So we've got 5 times 3x plus 2 minus 10 equals 30. Okay, sometimes students make a mistake when they distribute through. We've got to be very careful when we distribute through. That 5 is going to be distributed through the 3 and distributed through the 2. Now, I stop there. Why? Because of the parentheses, right? So be very careful. A lot of times I've seen students when they just start out in elementary algebra try to multiply that 5 through all of it, and it doesn't. Okay, the 5 stops with the parentheses. So you distribute it through and stop at that set of parentheses. So what does that give you? A 5 times 3x, it gives you a 15x. 5 times 2 makes it 10 minus 10, and that equals 30. Now, before we start doing anything as far as moving across the equal bars or dividing, we always look and combine like terms. On the left-hand side, we have a positive 10 and we have a negative 10, don't we? So those are opposites and they're going to cancel out, right? They're additive inverses. So that leaves you then with 15x equals 30. And how do we finish it now? Divide by your 15. And that leaves you now with x equaling 30 over 15. That reduces directly down to the number 2. Now we're going to talk about fractions. So I wanted to do the whole numbers first before we really delved into fractions. So now let's talk about fractions. How I'm going to have you do these fractions is I'm going to have you clear them out. There's different ways of doing these. I'm just going to have you clear them out. So let's look now at question. We'll start with an easy one. How about question 54? Okay, so question 54, we have r over 8 equals a negative 3. So we're going to learn now the basics of how to clear out a fraction. When I look at my fraction, I have the 8 down below in the denominator. So what I'm going to do is I'm going to multiply each piece by an 8. You have to do it to everything. You can't just do one side, you have to do it all. Now when I distribute this 8 through, those 8's, okay, are going to cancel because 8 divided by 8 is 1 and it goes away. So those 8's cancel and that leaves you with an r. What about the other side? 8 times a negative 3, it has to be distributed through. 8 times a negative 3 is a negative what? 24, and there's your answer. Okay, let's look at another one. Question 57. Similar concept here. This one requires one extra step. We've got a minus 5/6 t equals a negative 15. So what I'm going to do is I'm going to get rid of the fractions. So I have a 6. So I'm going to multiply down below. So I'm going to multiply everything by a 6. Okay, now what's going to happen here? Well, 6 divided by 6, those cancel out. See, one's on the top, one's in the denominator. Those are going to cancel, and that's going to leave you with a minus 5t. Right? Those 6's cancel, and that leaves you with the minus 5t. What about the other side? We have to distribute it through, and we've got 6 times a negative 15, and 6 times a negative 15. That makes it a negative 90. Now the fractions are gone. We do have one extra step versus the last one, and we need to divide everything by what now? Now, not just 5. We need to divide everything by a negative 5. That clears the negative out as well, and that leaves you now with t equaling negative of negative makes it positive, and 90 divided by 5 is an 18. So that would come out to give you an answer of t equaling 18. Okay. So you can combine the fractions together or clear them out. We're learning how to clear them out in this section. A lot of times I have you clear them out. Now, if you have multiple fractions, you can clear them out all at once. So one that has several fractions in it would be question 66. Okay. And this one you can either combine these together or you can clear them out. I think, honestly, for most students, it's going to be easier to clear them out. And we're going to do several of these where we clear out the fractions. A lot in this section and even more in the next one. So I want to clear out my fractions. Now the first thing I look at is I look at my denominators. And I've got a 3 and I've got a 9. What's the least common denominator of 3 and 9? 9, right? Because that 9 goes into both of them. Is everyone okay with that? We're going to really take our time with this one and the next several so we see how to clear the fractions out. So our least common denominator is a 9. So we're going to multiply every part by a 9. And what happens is we divide by the number down below in the denominator. We multiply by the number on the top in the numerator. So 9 divided by 3, okay? 9 divided by 3 is a 3. 3 times 2 makes it a 6x. Divide, then multiply. 9 divided by 9, that's a 1. Times a negative 5, that makes it a minus 5. Bring down the x. And do not forget the other side. 9 times 4, well, 9 times 4, that's a 36. Now, what can we do from here? Okay, these have the same on the same side, right? They have the same variable. These are like terms, so these can go together. And 6 minus 5 makes it a single x. And now we have our answer, which is x equals what? X equals 36. Now, sometimes students get confused as to when to stop. How do I know I'm done? I know I'm done because I have the variable x by itself on the left-hand side. Numbers are on the right. That's what we want. Nothing in front of the variable, just the variable by itself on the left, numbers on the right. Now let's try one that has more fractions. 73. Question 73 is next. We've got 1/3 x minus 1/4 x plus 1/12 x equals 3. Okay, so we need to start off with our least common denominator. What's the least common denominator of 3 and 4? Okay, if I look at my fractions, I've got a 3, a 4, and a 12. Least common denominator of 3 and 4 is going to be what? 12, isn't it? Okay, well, we already have a 12 here as well. So I can multiply everything by a 12, and that should take care of all of my fractions. Right? Because 12 goes into 3, 12 goes into 4, and 12 goes into itself. So draw the arrows, and let's take our time. 12 divided by 3. 4 times x, that makes it a 4x. Then we have our minus. 12 divided by 4 down below is a 3. Bring the x with it. 12 divided by 12, well, those cancel, right? That leaves you with a 1. Times x, that leaves you with an x. And what does it equal on the other side? It equals not 3. 12 times 3 is a what? 36. Where do students make a mistake? The commonly made mistake is right here. The most commonly made mistake is someone will write down 3. Okay, it's not 3. What do we have to do? Draw our arrows. It goes through each and every part. Each piece gets the 12. So make sure that you write 12 times 3, which is that 36. Now what can we do? Now we can combine. So we have on the left-hand side, we have a 4, a minus 3, that makes it a 1, plus another x, that makes it a 2x, right? And that equals a 36. How do we finish it? Last thing we do is divide. Always the last thing is divide. Divide by your 2, and now we've got x equaling 18. We're going to be using this technique a lot when we clear the fractions. If we have an equal sign, we can always clear the fractions. Sometimes it may not be the easiest thing to do. You might want to work with them, but most of the time, though, we clear them out. Let's do one more, and then we'll take a short break. So 74, we've got 2/5 x plus 1/10 x minus 1/20 x equals now 18. So let's talk about now our least common denominator. And what's the least common denominator of 5 and 10? 10. And what's the least common denominator of the 10 and the 20? That's 20, right? Okay, so what do we know? We know that 20 is going to clear out all of our fractions. So now we put our 20 out in front. And we're going to multiply through. Divide by the number down below. Multiply by the number on the top. Okay, and I'll put the calculator up here so you can actually see what we're doing. So let's start with the first one. What do we do here? Here we got 20, right? We're going to divide it by the 5. And then we're going to multiply it by the 2. And that gives you now 8x. What about the next one? 20 divided by the 10, right? That leaves you then with a what? 2 times 1 makes it a 2x. So that's gone. And what about the last one? What happens here? 20 divided by 20, what does that leave you with? 1, yep. But what is my x? It's not a positive here. What is it? Negative, so don't lose your sign. So you're correct, but it'll be a negative x, because that negative comes down with it. And do not forget the other side. What's the other side going to be? 20 times 18. And 20 times 18, that gives you 360. Now we can finish it. What do we have? We have an 8x and a 2x. That makes it 10. 10 minus another one makes it a 9x. And 9x now equals 360. And what's my last step going to be? Okay, divide everything by a 9. And that leaves me now with what? Yep, divide that by 9. And now we've got it. We've got x equaling now 40. And that's your final, finished answer. We're going to take a short break, and we're going to come back, and then we'll look at 2-3 and 2